Ladies and gentlemen, tonight we're going to look at Terraform 2022. And let us just jump right into it. If you already know how Terraform works, then that's good. Because Terraform, it works exactly the same as it did in 2021 here in 2022. So that's a good part. Of course, there's a lot of there's been a lot of providers that's been added, and also the existing providers has been of course maintained and upgraded a lot of times during 2022. And if you don't know what Terraform is, then I will explain it to you right here and show you some tutorial examples with S3 Bucket and with Google Cloud. So what does Terraform do? Terraform is code. It is infrastructure as code. So this means that you have a lot of infrastructure on the clouds, maybe on different clouds. Maybe you use both Google Cloud and Amazon AWS, which I'm using right now. Then you can actually script and you can create all of these resources with Terraform. So Terraform is a scripting, it's a scripting framework, so to say. And there's a free version, a community version, and then there is there's a paid one where you can use their clouds. The cool thing is there are so many providers. A provider is just a plugin. That is where the heavy lifting is done. That is done inside the provider. So there's a plugin that actually knows how the API to, for instance, AWS or Google Cloud works, and then it would actually and then it will actually call the right API. It will execute the correct API actions in order to get the final state that you decide. So you just write down what kind of final state do you want, which resource do you want, with which properties, and then the Terraform provider will actually figure out how to call the Google Cloud and create those resources. This means that every time you have a new provider, a new plugin, of course you have to read up on the documentation for this provider. The documentation is quite awesome for all of the big providers at least, so this is no problem at all. And there's code snippets that can be copied from each provider's documentation page, so to say. So this is the setup. This is architecture. We have a Terraform client, and then we have a Terraform provider, which we download, and it happens automatically when you mention a Terraform provider in your .tf scripts. Then Terraform will automatically download that when you call Terraform init. But we will show this in just a minute. Then we have the target API in the right side right here, and that target API. It could be AWS API, it could be Google Cloud, it could be Azure, it could be DigitalOcean's cloud, it can be anything, right? And then what we can actually focus on is the resources. A resource is something that you want in the cloud. So that is like, it could be a bucket, which I'm going to demonstrate here in just a couple of minutes. It could also be a virtual network. It could be a small server that you want to spin up. It could also be a Kubernetes cluster resource. So there's very good support for Kubernetes cluster. So this means that you can define all of your resources for your Kubernetes cluster inside a Terraform file, and then you can then run that just like with the rest of your infrastructure. Personally, I think that if you want to set up your resources inside a Kubernetes cluster, I would actually use Helm instead, because the Helm file and the Helm syntax is almost the same as the default Kubernetes YAML syntax. It is actually the same syntax, you just add some templating. So, but of course it's a matter of opinion. If you use Terraform to all of your other resources, then of course you would also use Terraform to your Kubernetes cluster. Of course you will not switch technology just for the cluster. Okay, but the workflow for a developer is like this. You have to write, and this is from Terraform.io, where you can find all the documentations and you can find out how to use it. You can also find out how to use the cloud, the Terraform cloud platform. So we have a configuration file, and we have a state file. The state file is being generated automatically. The configuration file, that is actually what you create. You define what kind of resources you want. You want a bucket named Mike, and that's what you do in the configuration file. And then you call the Terraform plan, and a plan will actually be created, and you can follow this plan, and you can see it's human readable, this plan. So this means that you can see that, okay, these resources are being created, these resources are being being changed and these resources are being deleted. And then if you want to, then you can then call apply to the plan afterwards. If you want to, you can save the plan so you know it will be exactly the same variables that will be used when you call apply. That is one option. Another option is just to call apply dynamically without using a pre-saved plan. And that means that then you would then the variables of course can change, because usually you would use variables inside your files, because for instance you want to set up environment variables, for instance. That could be one use case. So okay, enough talk. Now let us see some code, Mike. Yes. First of all, before we see some code, you actually have to have access to your clouds. That means that you have to have set up some credentials, and I've done that with the Google. There's a Google CLI where I have followed the guide for actually setting up the Google CLI. This means that my WSL, my Ubuntu instance, it has access to Google Cloud. This means that I can call the Google CLI commands if I want to, and then I can actually access my cloud. So just so you know that the credentials are not handled directly in Terraform and through the providers. It is handled indirectly. You have to mention a file. You have to configure it, of course, as usual. So you have to configure it actually per provider. That's what I'm trying to say. And if you don't configure anything, then it uses the environment's credentials. And for instance, if you're dealing with an AWS cloud, then you have a file inside your home folder .aws, and then there you will have a credentials file with an access ID and an access token. But there are many different ways of actually providing credentials, but you have to provide the credentials, of course, or you have to have a default set of credentials running on your machine, so you can access the clouds. That is, of course, that's of course sound logic. And if you don't know how to set it up, then there are very good guides also inside at terraform.io. So the workflow is actually we go and look for the registry. So let me just write registry Terraform right here. So you go to the registry Terraform, and then you find the provider that you want to play around with. In this situation right here, I searched for Google, and then I got this, and here I can see the documentation for how to get started. I can also press the purple button right here, then I get my provider. This means I will actually get a code snippet that I need for my .tf file. So I need to copy this part right here. Copy, and then I'll paste it in my .tf file, and I can name my .tf file whatever I want to, but the standard is that you have to have one main .tf file, so the next developer can kind of figure out what you're trying to do by looking into the main .tf file. But there's a lot of documentation right here, and then I will find, the next thing is I will find the resource that I need to manipulate in my Google Cloud. In this situation right here, it is the storage. It's called cloud storage, I think. Yes, it's right there. Cloud storage, and then there are some good examples right here. Copy, paste, and then you put in your own values. It's very easy. It's very simple, actually. So yeah, register terraform.io, a very good page to know about. I'm using VS Code, and I've created two folders right here, one with a Google example and one with an Amazon example. I could have merged these two folders into one, and then I could have just had both of these resources in one folder. So first of all, I'm going to delete some files because I don't want you to see these files yet, actually. So Terraform. Let me just delete this. Yeah, okay, that way it went, so that's good. Okay, so I just want to delete some state files because Terraform actually saves which state these resources should be in. So if you have created a bucket, then Terraform would actually know that this bucket has already been created from the local state file on your local machine, and this means that it can actually get out of sync. If some of your colleagues has maybe they have run something up in the Terraform clouds, or maybe they've run something on their own machine. This means that then your state file will actually be out of sync. I've created another video on how to get those files in sync again, but you should just think about that. They can't get out of sync, and the message is actually quite simple. It would actually say that this resource is already there, so I cannot create it. Another thing I've created right here, I've created one Terraform file. So this is all it takes. It takes one .tf file. The extension is .tf for Terraform. And then I have added one provider. So this is what I copied from the provider, the purple button from before. Here we have a provider setup. So these are the providers that I need. This will be used to download. This will be used to download the plugins, the providers, provider equal plugin here. So this means that then I will actually get the HashiCorp Google provider downloaded in a version 4.40 right now, and then I will configure it like this. This means that I will actually configure my Google provider with a project name which is Mike's Demo. And if you are familiar to Google Cloud, then you would know that you always need a project, kind of a project where you play stuff. It's kind of a mini cloud inside your cloud. It's just a logical grouping of all of your cloud resources. That's how Google does it. They name it a project. And that's actually it. Then we have then we have the resource. The resource consists of two arguments first. Of course, we write resource. Then we write what kind of resource is it. That's the type. This is found in the documentation. And then the second part is the name of the resource. The name of the resource is important and should never change, because if you change the name of the resource, then Terraform would not know that that this new they would actually not know the states of your resource any longer. So you should think twice before changing these names, because this is a logical Terraform name, and this will be used in the state file to keep track of which state these cloud resources have. And there's a convention which says that you need to use underscores. You should not use dashes in the names, just so you know. Then we have a name for my bucket. This means that I want my bucket to be named Mike's Demo bucket. And then we have location, Europe, and force destroy. These are just extra metadata for my bucket. And this means that if I destroy my bucket, then all of the files will also be destroyed inside it. This lifecycle setup right here, it means that when my files are more than 3 days old, then they will automatically be deleted. So that was that. Let me just fix my mic. Yeah. So that was my resource. So then we have some actions that we can call. The first thing we always call is init. This is where the download of the provider is happening. This means that now I will, the plugin will be downloaded. And let us see what happens now. We call init. I'm using this package.json file because then I don't have to type Terraform init out in my console. And I've not shown you how to download and install Terraform, but it is quite easy. It is very, very easy. If you go to Terraform.io, you just press download and then you choose your operating system, Linux for instance. I had to run these 3 lines right here to install it on my Ubuntu instance. There's also for CentOS and for Fedora, Mac OS if someone uses that. Then there is for Windows also. And so that's it. It's quite easy to install. And then after installing it, then you have access to the Terraform to the Terraform client. Some people actually like to alias this to TF, so then they can just write TF something, which makes it, of course, a bit shorter. So now Terraform has been successfully initialized. Thank you very much. I'm pretty happy with that. That means that now I got a Terraform folder, and I have my provider has been downloaded right there. It also creates some log file. It's an internal log file that it uses itself. It logged the versions to 440.0. So that's good. That's cool. That was step 1. So then the next step is to run. And again, I created this package.json file by writing npm init, and then I just pressed enter. And then I got this package.json file, and then I went to the script portion right here, and then I added my own script, so I can just right-click and click Terraform plan instead of writing Terraform plan. This is just because I'm lazy. Some people would also create shell scripts that can be right-clicked and then run instead. Here we have plan 1 to add, 0 to change, and if we look a bit in the output, then we can actually read it. It is human readable. So Terraform will perform the following actions. Anyone can read this, right? Look how easy it is to use. So here we have the type of the resource, the name of the resource, Mike's Bucket on Google. Here we have the resource, there's a plus in front. This means that all of these things will be added. And there you can see there's a lot of fields, a lot of properties that I have not filled out. Then the default values will just be applied. And this is also why it says that it will be known after apply. This is because the cloud would actually create these values right here. The ID, of course, will be created from the cloud. Then we have the lifecycle rule, also added, plus. Mike, please apply it. Yes, I will apply it now. So I'll press apply, and then you have to say yes. Of course, you can add an extra argument, so you don't have to write yes if you're running this from a command line or from a CI server. So now we applied it. Let's see what actually happens. Apply complete, resource 1 added. Let us go see if we have some Google resource inside so this is my Google Cloud project right here, Mike's demo. And if I refresh this page right here, then we can see that now I have Mike's Bucket right here. Oh, I'm so happy. It actually worked. Of course, I'm not surprised, but I pretend to be surprised that this is a huge thing, but when you're dealing with Terraform, it is not a huge thing. It is so easy to use. There are some things that you should not use Terraform for, in my opinion. That is for file transfer. Then I would use a small script that actually uses SFTP instead. The file transfers to buckets especially can be a bit difficult, but try it out and see what kind of experience you will get. But sometimes it will actually not overwrite the file, even though that you have set up that it should use versions of the file, and that means that it should actually upload a new version of the file every time that you press upload. It's like the providers, they don't know how to do that. File upload, I would use SFTP instead for that. That is what that protocol is for. You should not use Terraform for that, even though it is possible. Yes, so that was my Google bucket. Now let us try something a bit more complex. I have an S3 bucket example right here. Here there are many more files. I have a main.tf file again. And again, this time it is AWS I'm using. So this is my provider. I have my resource right here, an AWS S3 bucket. This is named my AWS bucket. That's just the Terraform name. The bucket name in S3 is Mike's demo bucket right there. I add some tags right here, so we have some metadata up there. And here I'm using a variable var.purpose. This is so easy. It's so easy to use variables. You just write var.purpose, and then whatever the variable name that you defined in the variables.tf file. I've defined one variable right here, purpose, and it has the type string. You can use objects, you can use lists, you can use, of course, numbers. There's a lot of types, so you define the type right there, and then you have to set the value somewhere. Of course, you can set the value command line just by writing -var and then the property plus the value, or you can set it in files. It's more usable, I think, to have them in files, because then you can also commit those in your Git system and have them under version control. Here we have the purpose equal to, I would like to show a demo of Terraform. And then again, I have an output.tf file also. That is only just to show that that this file is sometimes there. That is if your provider actually generates some output while running whatever it you run, then you can get that from the outputs file. So this means that sometimes you can actually extract data from the clouds also, and then place it in the output file, and then you can use that output for the next provider. So that means you can actually kind of have your clouds actually work together that way by taking a value and then using that value in the other cloud afterwards. So it is kind of a cloud integration also. Oh, that's too far. But outputs.tf is for if there's an output stuff. There'll be no output in this example right here. So I have my main.tf, that was what we just saw. Extra bucket, this is just to show you that you do not need to name your file main.tf. You can name them whatever you want to. All of these TF files will be evaluated and looked at by by Terraform. When you start up your plan, it will actually load all of these files, and you'll see, okay, this is how it actually works. And this is also why you probably saw that the order of all of this, it does not matter which order this is in, because the whole file will be read by Terraform before it will actually try to see if everything's okay, before it tries to parse it. So here we have the provider, and here we have resource, and we have the configuration of my provider right here. I'm using, this is a Frankfurt server. This is EU Central. This is Germany. So runtime values, package. Let's start now. So we had this extra bucket. The only thing with this extra bucket was that it is just an extra bucket, and the name is Mike's extra bucket right there. The important thing is that it has its own unique resource name, or Terraform will also complain, and that is actually why we run the plan. Let me run init while I continue blabbering a bit. Here we have, we call init because then we get the provider right here, and then we call plan. And the reason why we call plan is actually, this is to find errors. Usually it is very important to cloud resources can be they can be critical for the business, of course. So it is very important that what we do is actually correct, and that is why we have this plan step right here. Then we can see what is actually going on before we execute it. Here we have the var file right here, and if I wanted to save it, I could save it with --out and then some kind of file name. Then I could actually save the plan, and then it would be executed with the same variables that the plan was actually run with later on. But in this situation right here, I'll just run the plan just to see that everything works, and then I'll run apply afterwards. Here I have my variable file. This is the variable, this is the values, the variable values. The definition is in the TF file, but this is the values right here. So this means the Terraform by default will not look at any TF file. I have to tell it that it should go look for values in this file right here. And let us run the script right now. Let us run the plan. To add, yes, that's quite cool. You see a lot of website stuff, and that is because these buckets can be used actually to set up your own to set up a website, and it should work quite good actually. I've not tried myself, but you just place an HTML file inside your bucket, and then you can set these website. You can set this website tags or properties, and then you would actually know which one is the default file, and then you just place your JavaScript up in the bucket, and then you can have your then you can have your website right there. You can set your error document, index document. It's almost the same settings as you would set in an Nginx server, for instance. Here we have index document right here. So there's a lot of there's also some routing rules even. I might try that one day. That's actually it sounds fun. I'll press apply. Let us see if we get some resources in AWS. Here are my buckets. I did not wait for it to finish. I had to press right yes, yes. Of course, I could have added. Command line argument, so I don't have to write yes, but that's okay. So now I got 2 resources added. That's fine. Let us go to S3 right here, and I'll press the refresh button. Yes, Mike's demo bucket, Mike's extra bucket right here. Let us go look right here. And here we have some properties right here. And we have this one right here. We have we have the data down here. Purpose, I would like to show a demo of Terraform, my cool buckets, only for PDF files, environment, integration. And that's actually it. There was another situation. Let us now change stuff, because apply with alternative purpose. Look right here now, instead of using the variable value file, then I will use then I'll just set the purpose on the command line like this, -var purpose, and then then let's see what actually happens, because now we have to change something. And again, we can see right here we have 2 things to change, and then if we go look up here, then we can see it is the tag purpose that I want to change to from I would like to show a demo to something else. And yes, that's fine. It is always good to read what is going on, because sometimes you would actually see, if you want to change the name of the bucket, for instance, then you would see one to destroy, one to add, because then it would actually have to destroy the whole bucket to create a new one in order to change the name of the bucket. That's how many of these buckets actually work. So it's always always read always read what's going on before. Let's see what happened now. It's done. Yes, 2 changed. So we will actually go back and we'll say refresh properties. And then we should have something else. Yes, there is something else right there. So that is it. This is why it's so easy to use Terraform, right? We just say what we want. We just say, we just mention the result. We just mention the result in these resources right here. And these resources, it's not something that you have to remember or think of yourself. You look up the documentation, you copy the examples that are there, you paste them, and then you place in your own values. It is so easy to use. Thank you very much for watching. Have a great evening. Hope to see you again soon. Bye-bye.